Good morning, everyone. My name is Lodovica Marchesi, and I'm a PhD student of the University of Cagliari in Italy. Today, I'm gonna show you a method for the automatic generation of blockchain agri-food traceability systems. So, supply chain management, product provenance, and quality certification are among the first and most popular applications of blockchain technology due to its intrinsic characteristics such as trust and inalterability. However, the system in the state-of-the-art tend to be specific to the particular production and production process. In our work, we propose a general-purpose approach, proposing a system that can be configured for most agri-food production, providing a methodology to make the development of agri-food supply chain application more easy and more efficient. It is based on smart contracts written in Solidity and application interacting with them. Both configure using json files describing the specific system to be managed. So we studied the agri-food production domain and we found that virtually all agri-food supply chain systems start from one or more primary sources, such as soil, herd, behaves, lake, sea, and so on, and produce a primitive resource, the harvest, milk, raw honey, fishes. Then this product is transformed, possibly several times, until the final product. Events relevant to the process can occur in each of the phases, and since this problem is too complex to be tackled top-down, we decided to adopt a bottom-up approach using analysis technique and object-oriented design. To develop such a system, we firstly need to determine the actors, concepts, and entities that emerge and recur in this type of system, then determine the relationships between these entities, and determine all the events of interest in the process. After that, we design configurable and modular building blocks that are the smart contracts, representing the identified entities and relationship in order to represent them on the blockchain. Finally, we semi-automatically map the user interface needed to interact with the system. So we identified the key actors of an agri-food system. For time constraints, we won't have time to describe them all, but as you can see, the actors involves the administrator of the system, the different kinds of producer and sellers, the end customer, but also certification authorities or analysis laboratories, and of course the device used to interact with the system. Each actor, each of these actors in the system is identified by a unique address able to send transaction to the blockchain. The actor owns the private key associated with the address, thus being the only person able to send messages from that address. The main entities involved in an agri-food supply chain are the list of all the addresses managed by the administrator or the owner of the system to grant the proper authorization, the producer, a farmer or a firm, a productive resource, which is typically a field or a group of animals, a product, which is the result of a transformation from a productive resource or from another product. A token, which is not the traditional token you probably heard about, but is a number representing the ownership of a specific amount of good. We use it in the system in order to guarantee the original quantity of good, since once it is created, it cannot be increased. And finally, the notarization of documents. It must include the hash of the document, the registration date, and the link to the document, typically stored on a server. Obviously, it can also include other data. So, once identified actors and entities, we identify the main events. The system manages two types of events, the transformation ones, so all the events performing a transformation of the resource or of the product, for example, the merging or the splitting, and the documentation events that that associate documents to a resource or to a product. Obviously, we won't have time to see all the events in details. To all those interested, I refer you to the paper. Now, after identify the actors, concept, and events related to the process, these system smart contracts are created. So depending on the specific use case to be implemented, the developer can design either dynamic, static, or Oracle-driven smart contracts. At the moment, in our system, the smart contract is a static file, regardless of the use case, listing all the relevant fields for each concept. So we will have a smart contract for every producer, for every resource and product, and they are automatically generated from these JSON files. The entities and the events we saw up to now are able to cover virtually every production process. Once we define the events of a specific production process with their data, constraints, and authorization, it is possible to automatically generate an application able to create and edit these events. Obviously, the style and the appearance of the user interface can be customized, and the navigation among the events, the products, and the productive resource can be automatically programmed starting from a QR code written on the final product. Now, I will briefly describe a case study on olive oil production to show how our approach works. So the system allows to trace the olive oil production from the agricultural treatments on the field to the olive harvest, the mill, the bottling, until the sale of this bottle to a wholesaler, to shops or supermarkets. All the concepts of the system are cataloged in specific JSON files with the relevant associated fields. To make the system usable even for users with a low level of experience, these JSON files can be created through an easy-to-use back-office application we provide. In particular, we will have a JSON files for the list of the actors, for the list of companies involved, producer or retailer, and so on. In the figure, you can see the architecture of the system. As you can see, the system consists of the blockchain, in our case, the Ethereum one or more servers that manage documentary data on the cloud, such as documents, images, maps, video, and so on, and which can also be the website of the consortium or of the farmer. And from application running on devices obviously connected to the network. So now let's see some of the basic interaction that make up the system. A farmer, for example, with his smartphone, can easily and quickly record the treatment carried out on his crops, the harvest, and the stage of its transformation. The analysis laboratory can record the results on the cloud server and certifies their fingerprint on the blockchain, for example, with a program that runs on a PC. An inspector of the consortium examines the certified history of the oil in production and in turn records its certification. A consumer, by reading the bottle label with a smartphone, can read the entire history of the oil contained in the bottle, from the olive grove to the bottle itself, certified on the blockchain, and can also read the data on the cloud. In this figure, we can see the simplified olive oil production flow. So the agro-industrial products are denoted as rectangles, while the associated events as documents in the flowchart notation, so the rectangles with the wavy bottom side, and can possibly be multiple. Transformation events, denoted in the figure as ET, are always single and are associated near the right side of product or resources and cause them to be transformed into other products or divided into batches. So in the example shown, the olives come from two olive groves, 1 and 2, and once harvested with a single event, the harvest, they are divided into two lots, olive 1 and olive 2, immediately before milling, which takes place separately for the two lots. Consequently, they have no other associated description events. So now let's talk about the advantages. Nowadays, with the globalization of the markets, traceability systems are important to ensure the safety of a food product and prevent food fraud in the food supply chain. Systems based on blockchain and smart contracts allows this traceability without the need of a third party. This leads advantages to all the parties involved in the process, from the consumer, who can truly know the product he's purchasing, to the authority, whose control are facilitated, and of course the manufacturer, who can easily certify his production. Finally, times and costs are reduced while maintaining a high level of security and trust. All right, concluding, to the best of our knowledge, this is the first attempt to automatically develop a custom distributed application for agri-food supply chain by building configurable smart contracts to be assembled together. And we truly believe in the innovation of the proposed method. Moreover, he was actually used to develop different real systems, thus confirming its efficiency. Note that our flexible approach may lead to high gas costs in creating and updating smart contracts on the Ethereum blockchain. For this reason, we advise to use a permission blockchain, publicly accessible for reading as a backbone, in order to minimize these gas costs. Future work may include the creation of a domain-specific language, the generalization to generic and non-Ethereum-like blockchains, and of course also the generalization to other kind of supply chain and not only the agri-food ones. Okay, so this concludes my presentation. Thank you all for the attention, and if you have any question, please do not hesitate to ask me. With the no more.
Hello, everyone. Good morning in Europe. Probably you did not, you do not expect to find me here, but we are having some issues with the backstages and the chairs and everything. But the author is here, which is what really matters, and she is more than eager to answer your questions. Okay, you see me, you see the side of my face because the camera is not in the right place. This was not prepared in advance. So please, if you want to make questions, go ahead. And if not, we will start a conversation. I will start a conversation with Ludovica, which will be pretty casual because obviously I have not watched the video, so have little idea besides the title that what the paper is about. Automatic generation of blockchain agri-food traceability systems. Well, have not that much idea about the paper, but I have a little bit of idea about the topic because I have reviewed some papers on the same area. Is it that important, the agricultural sector? I mean, that's a claim. The agricultural sector is important, and is it so critical to introduce technologies which are complicated as like blockchain to ensure that traceability and everything is correct? Are we overkilling? Is it really necessary? What is your opinion, Ludovic?
Well, since your voice come and also I think that you asked me what's my opinion about the idea of introducing new technology in
Complicated
this
technology as blockchain.
complicated. Okay. Well, the point in introducing blockchain technology is all about trust. You know,
Okay.
since blockchain is introducing a new way of trust. So you can trust someone without knowing it, without knowing him or her. You know, that's the point of introducing the blockchain in this kind of fields. And for what concern agri-food supply chain and traceability system, it's I think that it's the point is to have trust on what you're purchasing, what you're, you know. So that's the point of introducing blockchain. I think it's something really new and something really important. And
I
Yeah, you go.
No, no, no.
No,
You
I
go.
go.
You go. You go.
Okay. And you say that it's complicated. Well, the point of our paper is to do it in a non-complicated way. So we are proposing a system to automatically generate all both the backend system, so the smart contracts running on the blockchain, and also the user face, so the front end system, to do traceability on the blockchain in a easy way.
Most of the business, most, well, I am making a claim that I cannot sustain. Spain. Let's put in my
That's it.
context. Okay,
Sure.
most agricultural businesses are rather small farms or relatively small farms that are much more concerned about the animals and the food supply, etc., than on computers. So how do you plan, or what is your idea to provide uh, this service? How can small farms and businesses use this technology that is complex? We know you want to make it simpler, effectively on a daily basis. What do they need? What do they have to change?
Well, what a farmer, for example, needs is just a smartphone. So it's not that complicated to use, you know?
Is that interoperable? I mean, because there may be different providers, solutions, and at the end they have to understand each other. So, what about interoperability? Is the solution that you are proposing being able to use by different operators in the food chain, in the food supply chain?
Of course, yes, yes. Well, if with interoperability you mean maybe different farmers, but also other entities in the supply chain, like for example, I don't know, laboratories, inspectors. Yes,
The
it's meant to
public,
be.
the public, for
Yeah,
instance,
obviously the end
consumers.
customer. Yeah, the end customer. Yeah, all these people only need to have a smartphone or a laptop, or and obviously
Hello.
an internet
Hi,
connection.
Roberto Tonali
Hello.
has joined us, so
Yes, I
everything.
realized how to join you. Okay.
Okay, so everything is fine right now. We're having a very nice conversation about blockchain, agriculture, and well, I give you the floor if you have any question. I'm going to make my last one. Did you put this in practice in any pilot project? Because I know that the European Commission is funding this type of research. Do you have any connection with them, with practical projects, with operations in the field?
Yes, we do. We implemented this kind of system for different, well, in different fields. For example, for the cheese production of a local one in Sardinia. Well, and it is part of a bigger, as you said, a research project of the region. Yeah. So we did
Mhm.
it. So we have more than one of this project really working, actually working.
The, que- the,
So
yeah, sure, go ahead. I was trying to make a
yeah, I
question.
was. Yeah, I was trying to finish to answer your previous question. So the only thing that a user, which can be a consumer or a farmer or an inspector, the only thing that he has to do is a mobile phone or a PC and an internet connection. The idea of such a system is to provide something which is really user friendly. So, depending obviously on the kind of actor, they will have a different user interface. But and obviously they also have different activities that they want to do on with this system. For example, a consumer with his smartphone can read the QR code written on the final product, and from that is able to see all the supply chain process. So he know, for example, if he's purchasing a bottle of oil, all the history from to the bottle from the groves, the olive groves.
Mhm. Um,
You know? Okay.
People, and myself as well, mix up things like blockchains and bitcoins and everything. It looks everything the same. For instance, when we are
Yeah.
told about bitcoins, they say, "Wow, they use a lot of energy for mining and everything." Is that an issue in the blockchain as well? I mean, do you need very powerful servers with lots of processors, lot of energy, or is it a straightforward process that will be economically released and everything? How is that for the naive person like me?
Yeah, sure. Well, I think that the energy problem is a problem for blockchain. Yeah, the one such Bitcoin. So the Bitcoin-like blockchain, we choose a consensus algorithm, which is quite expensive in terms of energy. But there are different kind of blockchain. For example, ours do not require this kind of energy, this amount of energy.
Because
So
if not,
it's
we can use the energy for cooking, and that's probably a
yeah.
better usage of energy of electricity. So,
Sure.
but it is cheap. That is cheap, is what you mean. Huh? It's not that heavyweight and can be, let's say, easily implemented in, I don't know, commodity computers. Is what you mean. You don't need a special servers, special farms to
No,
make
absolutely
it
no.
work. Okay, perfect. Then,
No,
so again, go ahead, go ahead.
Okay.
no, I'm done.
Yeah, okay. So let
Thank
me
you very
let
much,
me.
Oscar.
No, I just wanted to say something for the public. Right now,
Yes.
it's 40 seconds to for the block for the backstage to finish for this live streaming part that we have. Okay, all the attendees and all the people in this backstage and this we three, actually, Roberto, Ludovica, and
Yes.
myself, we will see when the time finishes a pop up in the bottom right corner. It's greenish, it's green color, and you will see a button that says join to the backstage. So you can click there, okay, and you will be taken automatically to the
So
backstage.
everyone will be redirected in the backstage.
Exactly. Or you can
Okay.
stay in this room and you see the next presentation. Thank you very much, guys.
Thank
Thank
you.